if you are given, suppose you are given with the formula C5H10, suppose examiner gives you the formula C5H10, and
Yes.
examiner asks you that which homologous series or from which homologous series this compound belongs, explain your answer. Let me write it.
Yes.
What? 1 minute. Name the homologous series. Name the homologous series. Logos series, and explain the reason for your answer.
Yep.
Think about it, please, and then come up with the response. It's a 2 mark
Okay.
question. It's a 2 mark question as per the IGCSE specifications. Take your time.
Yes. Okay, got it.
Answer the question.
Name the homologous series and explain the reason for your answer.
Wait.
Firstly, this is
Yes, please.
firstly this is alkenes.
Wait. Let me write it down. It's an alkene. Okay. Reason?
The reason is because the molecular formula is C5H10, which tells us it's pent, and then it's ene because when in alkenes the formula is CnH2n, so it tells us whatever the carbon atom is, double will be the hydrogen. So it will be
Absolutely.
C5 and then H10, which is
Absolutely. That's
double.
that's very nice. That's very nice. You can simply write it. It is obeying. It is obeying the general formula. General formula. This is very simple way to respond. For alkenes, you can write it like this, which is CnH twice n. Am I right?
Yep.
Your answer was right, but uh, it is fine. You will get the marks, but I think this
Yeah,
is
but it's overcomplicated.
absolutely, and I think this is the more simplest way to express your
Yep.
answer to get the 2 marks, right?
Yep. Definitely. Agreed.
Any confusion?
No.
Okay, let's move to a few more structures and naming. Okay, dear. Before we start naming,
Yes.
I ask you to pick an error which I advertently made. I deliberately made an error.
The error is that we are missing one hydrogen.
That's very nice. That's correct. Very nice. So be careful that all the carbon atoms, they must have 4 complete bonds, 4 single bonds completed. That's very nice.
Yep.
Okay. Now, if you can tell me the name of this guy.
Okay, this one over here is bute,
Okay, fine. Bute.
and then it will be bute. This one is butene.
Oh, very nice. That's great because we have the carbon-carbon double covalent bond starting from the
Yes.
second carbon atom, right?
Yes. Yep.
That's well done. Well done, boy. Any confusion?
No.
Well done. Okay. One more. And again you can see it has a molecular formula C4H8.
C4H8, which obeys the alkenes. rule, general
Absolutely.
formula.
The general formula of alkenes, CNH twice N, it is 100% obeyed, right?
Yep.
Okay, one more, please. Okay, name this molecule, beta.
This one is but 1-ene.
Oh, very nice. That's great, mashallah. Very nice. Very nice. You picked it. You identified it.
Yes.
Very nice. Again, you can see the molecular formula is same.
Yes.
That is the C4H8, right?
Yep.
C4H8. It is obeying the general formula CNH twice N, right?
Yep.
So no problem at all. You are able to name the alkenes accordingly, right?
Yep.
That's right. Okay. If I name this guy, the top one, as the molecule A,
Yes.
and this gentleman I'm naming as a molecule B, suppose, you can
Yep.
see both of these molecules have the same molecular formula. Am I right?
Yes.
They
Yep.
both have the same molecular formula, that is C4H8, C4H8. Am I right?
Yes.
But they have different structure.
Yes.
That's why they are named differently. It is butene, this is
1 and
butadiene.
2-ene.
Am
Yes.
I right?
Yep.
So A and B are two such molecules which has same molecular formula but
But
different
different
structure.
structure.
Do you know what name is given to such molecules which have same molecular formula but different structure?
No.
Any idea?
No, I didn't.
Okay. Such molecules which have same molecular formula but different structure, such molecules are named as, please remember this word,
Structural isomer.
structural isomers, or simply isomers you can call them, no problem at all. Both words are acceptable.
Yes.
Either you can call them as the structural isomers or you can simply call them as the isomers. Fine.
Yes. Yes. And the structural isomers are basically compounds that have the same molecular but different structure.
Absolutely right. Any confusion?
No.
Please beware with this keyword isomers or structural isomers, whatever you name, whatever you call them, both are fine, right?
Yep.
So whenever you see such molecules that they have same molecular formula but different structural formula, they are supposed to be the
Yep.
structural isomers or simply isomers. Fine.
Yep. Yep.
And this phenomenon is called isomerism, right?
Yes.
You will learn more detail about isomerism and isomers in your A-level chemistry, inshallah ta'ala, right?
Yes.
Okay, let's move towards the next learning objective and the last learning objective of tonight's class, right?
Yes.
Making alkenes that
Yeah.
are, you can write how would we obtain alkenes? Am I right?
Yep.
Any idea about them? We learned about it. In
How
alkane,
would be happening?
in alkanes, we learned a chemical reaction cracking.
Yes.
Do you remember?
Yes.
In cracking, the larger molecules
Yes.
are being converted into the smaller
Yeah.
ones at a higher temperature and in presence of catalyst,
Yeah.
right? Because we know
Yep.
that small molecules are more useful, more in demand. They're excellent fuels, right?
Yes. Yep.
So same reaction, it produces alkenes. So let me remind you
Yep.
again that alkenes can be made. Alkenes are obtained. Alkenes are obtained by the cracking
Yep.
of long chain alkanes, right?
Yes.
Any confusion?
No.
For example, I'm writing a few chemical equations to show the process of cracking, right?
Yep.
C12H26. It's a long chain alkane. Okay. How can we say it's an alkane? Yes, right. How can we say it's an alkane?
We can say if it's an alkane, it follows the general alkane formula.
And what is the general formula for alkanes, dear?
CnH2n plus 2.
That's very nice. This guy is obeying, following, satisfying the general formula which is specified for alkanes, that is
Yep.
CnH twice and plus 2. That's nice. That's
Yes.
and we can simply write down the equation for cracking. You just need to remove the simplest alkene, which is C2H4. Am I right?
Yep.
I remove the simplest alkenes, and the other molecule can be written by subtracting number of carbon atoms. 2 carbon atoms you can
Yep.
subtract from 12. So how many carbon
Yes.
atoms will be left?
2 carbon atoms, so 10.
Absolutely. And similarly, you can
3, 10.
subtract 4 hydrogen from the 26.
That will be 22.
Absolutely right. That's how you can write down equation for the cracking of long chain alkynes, right?
Yes. Yep.
Any confusion?
No.
And you can see that this cracking is producing a mixture of alkene and alkane. It's an
Yep.
alkene and the other one is an alkane. Am I right?
Yep.
It's a 2 carbon atom alkene. It's a 10 carbon atom alkane. Fine.
Yes.
And you can prove it why this guy is alkene and why this gentleman is alkane. Fine.
Yep.
You know it very well by using the idea of the general formula. Fine.
Yes.
Okay. Recalling again the conditions for cracking. I'm recalling the conditions
Yes.
for cracking which we need.
Yes.
Okay. Let me ask you to recall number one. Yes, please try to recall the conditions for cracking, dear.
Conditions for cracking are high temperature.
Number one. Wait. Let me write it. You are absolutely right. High temperature. Yes, please.
Number 2, high pressure.
Catalyst. Number three. High pressure is required.
Yes.
One more. Very important. Do you think oxygen is present in cracking or it is done in absence of oxygen?
And cracking is done in absence.
Absolutely right. Remember it, right? Cracking is
Yep.
done in absence of air. Had it been done in the presence of air, the combustion will start, right?
Yep.
Because it's a hydrocarbon, and if oxygen will be there, air will be there, the hydrocarbon will
Yes.
start to burn and it will turn into carbon dioxide and water, right? We won't be able
Yep.
to we won't be able to get any alkene and any alkane. Fine.
Yes.
I told you when I was going through the process of cracking, and I ask you to recall it again, the commercial importance or economic importance, commercial importance of cracking, please.
Commercial importance of cracking.
Or economic importance. What is the importance of this cracking process in petrochemical industries?
It allows us to produce many products like smaller hydrocarbon thing products like petrol, diesel, kerosene, and then
Absolutely.
this bitumen.
Absolutely. Because no, bitumen is not there. No, 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 no. You are mixing the fractional distillation with cracking now.
Oh yeah, yeah. Okay.
Right. Let me remind it. Let me remind it. Large molecules are less useful and less in demand. So they are converted into small molecules which are more useful and more in demand. Am I right?
Yes. Yep.
Why small molecules are useful? Because they can burn easily, they are more volatile, they can be used as excellent fuel,
Yep.
right?
Yep.
Okay, dear. So we are almost in the dying moments of the class right now. So I ask you to recap the class, to wrap up the class, that what we did tonight. Yes, please. Hurry up.
Okay. In tonight's class, we learned about alkenes and like first we learned the allos, which is alkene, functional group in alkene, making alkenes, reactivity of alkenes, isomerism in alkenes, chemical reaction of alkenes. Then we learned what are alkenes. We learned alkenes are a homologous series of unsaturated hydrocarbons with general formula CnH2n plus 2, CnH2n, and unsaturation tells us that they need to have one or more carbon double covalent bond, and carbon-carbon double bond makes alkenes unsaturated. And then we learned that the test for carbon-carbon double covalent bond is add bromine water, and if bromine water turns red brown to colorless, tells alkene is present. We learned some display formulas of some alkenes and some molecular formulas. Then we learned that such molecules they're the same but they have one or more than carbon, so they're called isomers.